Hello and welcome to Maths 13 now. Oh yeah, Maths 12, that's a pretty long episode. 1 hour 46 minutes, that's incredible. Alright, so let's move on now. Like I say, it's not going to be, I really want to sort of keep the pace very, very slow at this point. So that's what I'm going to do. Okay. So for everything, I think we'll just say we'll do this. So that's for the whole of this. There's one way of looking at it. All right. So let's do something very simple to start with. All right. All right. So what I'm going to try and do is just use all the rules so far. And honestly, I may even just do this all the way up till 16. Now I think about it, because I really just want to get the hang of all the rules. So putting a bit more time of it here will be beneficial in the long run. Anyway, so let's look at the first one we got here. So we got this negative power. Now you recall, um, so to say like we had something like this, didn't we? A to the n equals 1 over a to the minus n. Or of course, a to the minus n is 1 over a to the n, however you want to look at it. So we've got this minus, we've got y to the minus 2 on top here. So what we want to do is, so y to the minus 2, if we follow along here, it's going to be 1 over y squared. So what we could do here is we can put, so we've got 1 over y squared, so that's the same as y to the minus 2. So it would be like x to the 5 times the 1, and then the y squared would be at the bottom. But of course, we don't need to put the 1 there, because don't need to, because x to the 5 times 1 is x to the 5. And then we've got the y squared at the bottom. So yeah, so the y squared, we got y to the 1 here, so that could be y to the 1 there. With the y squared, we're going to have y cubed there. All right, so, and then what is the other rule I could put in here is, is this one. So say a to the m over a to the n. Let me just write this bit out again. Times 1 over a to the n. All right, so yeah, so with dividing that, we can see how this works, because this first bit here could easily be like that, a to the n times 1. So you could have that like a to the m over 1 times 1 over a to the n. But of course we don't need to do it like that. We get rid of the ones, but the ones could be there. So that would be how we get to here, to get to this bit, and then to get to the next bit is fairly self-explanatory, because we know that 1 to the a n is 1 over 1. We know that 1 over a to the n um, um, is the opposite, isn't it? And that one makes sense because it's doing power and this is doing. A to the n times 1 a to the n times 1 over a to the n. Yeah, no, that makes sense. That makes sense. So say, yeah, so it's two. Yeah, yeah. I don't know what I'm thinking actually. This is obvious. It's obviously it's exactly the same as this. But anyway, so yes, that's how that works. And then once we get the multiplication here, 2 cubed minus 2. We just subtract the powers one from the other, and then the other way to do it. Of course, I will actually, you know. Um, so the other way to look at it is, so there's actually a harder way of looking at this one. So here we actually use this one. So we're looking at this a to the m, and we're saying that's 1 over a to the minus n m, and then so once we've removed this a to the m, we're replacing it with like a 1 basically. Yeah, it's cool to have this like yeah, you would do it in the opposite way like that. So you have a to the m over 1. That'd be the way I'd look at it. A to the m over 1 is going to be 1 over a to the m. Sorry, a to the m over 1 is going to be 1 over a to the minus m. And then 1 over a to the n is going to be so 1 over a to the n is going to be one over a to the minus n. So it's actually the opposite of what's going on here, which is a little confusing, but not that confusing. But it's a good way to look at it. So yeah, so let's just say that one more time. So a to the m over a to the n. So the first thing we do is we want to take this the numerator, which is a to the m. This a to the m over 1. So therefore, that will become a to the m over 1 will become 1 over a to the minus m, and then the 1 over the a to the n. The 1 yeah the 1 over the 1 over a to, the 1 over the a to the m, 1 over a to the n would become a to the minus n. Hmm. Yeah, it would become that, but that's not how it's. So I could have put. Yeah. So we could, yeah. So I suppose, yeah. So I mean, that was the thing, really. I could have just put a to the minus n here, but of course it's the same as 1 over a to the n. I mean, it makes yeah. I mean, minus n plus n is the same as n minus m. Hmm. All right. Yeah, I'll probably carry on. You know, I'm gonna be looking at this for a while, I think. Anyway, back to this. So yeah, this one is fairly obvious actually. Um, so yeah, so we've got the say. So we've got this thing here. So it's like so we could say it's like x to the m instead of a to the m, x to the m over x to the n. So of course, we're at this point we're not actually worried about the y cubes. Not much we can do about the y cubes. So it's going to be there. And then what we have to do is simply do let's take it out and do it here actually. Now I think about it. So we got x over 5 over x cubed. And the y cubed is not going anywhere, so let's forget about that. So let's see how many different ways we can write this. Um, so we can say that's x to the 5 times 1 over x cubed. What's the other way we can write it? X to the 5 times x to the minus 3. What other ways can we write it? We could have it. So all these are going to be the same. I'm going to write in this little piece here. So we could write it like that. So all these obviously are going to come out with x squared, but so these are all going to be x squared. But I just want to write them all down. So there's that one. Not really the case. True higher. 1 over x cubed. Yeah, I know it is the case, but I still don't like it really. But anyway, all right. So we could have 1 uh, over x to the minus 5 times 1 over x cubed. Hmm. All right. Yeah, I want to do more practice on this. I'm not happy with the amount I've done so far. Um, so I certainly do more of that. Yeah, I don't know. Maybe I won't do it on video. I'm not sure exactly how I'm going to do it. I probably will do it on video though, to be honest. Mm, I don't know. Yeah, no, well, it's not really a probably. I'll definitely do it on video. I, all right. Let's do something else anyway. But I think I'm probably just gonna. I probably will just keep it at this level for now. Because what's the point unless I can do all these things just really fast? Yeah, there's no real point. Yeah, let me just do this one quickly. Just want to do a couple of examples. This. It's weird because it works, but I just don't get why. Oh wait, no, it didn't work. No, it did. Um, I mean, I get that this is not changing it. This is not changing it. It's not changing it, but of course, it's essential for what happens afterwards. Because I know that when you have like a half and a quarter, a half and a fifth or something, you always want to multiply those two out. Because then you can be like, yeah, 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 like that. But I'm wondering if the fact that I know that is actually relevant or if it's actually a hindrance to what I'm actually trying to do here. Hmm. I can't decide whether I actually do know this thing here. Because I certainly never think about multiplying the one on top of the A with the D. I would never think of multiplying those as that of being of any importance. But in another sense, I probably do kind of know it. Like when I do something like 208 plus 120, I wonder if I do think about it like that. I'm not sure. It's like the cross, and then that. That is the shape of it, isn't it? But it's a line like that. No, 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 no. What is the line? Yeah. AD. No, that was the wrong one. A over B. No, oh, wait. So A over B times D. You could write this in different ways, can you? Times D over D. Uh, plus C. Nah. No, it's better to skip to the end with this one. But at the same time, I don't want to. But I still don't get why this one works. So it's so annoying. I'll need to look at some more fundamental stuff, I think, here. This is the one I think which is always. It's this It's this mix between division and the two branches of multiplication, division, and addition and subtraction. This mix of the two just always fucking pisses me off. 2/5 and 1/5. 2 times 5. 4 times 1. Yeah, I kind of prefer doing it like that. When you got the same denominator, it looks more interesting. And doing the fifths is quite nice. Yeah, it kind of actually does. It almost starts to make sense then I think about it. Because if I do 2 times 10, yeah, now it is actually making sense. That has actually kind of helped a bit doing it like that. Because when I think about it, it's like, fuck, I'll just write it how the hell I want. When I do 2 times 5 is 10. And then that's over 25. That is 2/5. So that's this number. And then I do 1 times 5 is 5. And that's over 25, and that's 1/5. So we did the AD there, did the BC there, Yeah, because if I've only done because 10 over 5 would just be the 2. So yeah, if I just took the denominator there, I'd have just got the numerator here. And the same with this one, I would have got that. Because sometimes I look at this thing and I think, wait a minute, there's a BD here and a BD here. Why isn't that minus subtract to nothing? That's honestly, that's sometimes what I think about. I don't get it. But I am kind of getting it now. Because you have to have that there. I guess the fact that you have to have it there is still not really getting it, but at least it actually makes sense for why it actually works like. Well, kind of. I kind of do like this idea. But anyway, let's move back. Anyway, I'm not going to focus on this anymore. I can, well, not today anyway. Like I say, I'm not hugely interested in what it doesn't really concern me either way. But anyway, right. So okay, so if we're at this point then. So this was the point we got to. Wait, did I actually go anywhere with this? No, this was actually the beginning here. Yeah, this is the beginning. So x to the minus 2 minus y to the minus 2, x to the minus 1 plus y to the minus 1. And I've already spoken about almost everything here, so... Alright. So the first thing is fairly obvious, isn't it? The x to the minus 2 is the same as 1 over x squared. That... At this point, I feel like I'm pretty confident. I mean that's one positive I can take out of this. At least I'm confident with this thing. That is obvious. 2 to the minus 2 is a quarter. 1 over 2 squared is a quarter. So that is, that would just make so much sense. It's not funny, but but anyway. So what was the next thing to talk about? Oh yeah, so alright, let's just get on with this one. And then of course we know what this is. This is plus 1 over x. Plus 1 over y. Let me just plus 1 over y. Okay. Maybe I don't need a... Why do you not need brackets for that? You don't put the brackets though, do you, sometimes? Alright, so here's the line which is the most confusing for me. And this is why I'm going to have to do this many, many times. I wonder how... I don't know though. Maybe I won't. Maybe I'll just try stumble on. That's probably what I'll do, I suppose. You can see we're doing the subtraction of two fractions here, so it's the same as what's on the right hand side there. So d over d in this case is y squared over y squared. B over b is in this case x squared over x squared. I do 1 over x squared minus 1 over y squared. And BD is x squared y squared here. Okay, so anyway, so that's that. And the numerator, and the denominator rather, so 1 over x, and then we times, because we're dealing with the addition of fractions, we just do y over y. So we do d over d there, and then we do 1 over y times b over b, or in this case x over x. So yeah, I mean, like I said, I suppose I do kind of get it. I think I just need to. I think I'm gonna spend the next few months just thinking about that particular one in my head, and try and visualize it in a different way. This visualization thing I think is quite nice, because it does not make sense to me that. Yeah, I've accidentally drawn a little thing here, by the way. That shouldn't be there. I can't. I don't want to get. Yeah, but yeah, it doesn't matter. All right. So the next stage is well, it's fairly obvious, isn't it? 1 times y squared is y squared. So 1 times y squared at the top. So just do a little dot. 1 times y squared is y squared here. 1 times x squared. It's x squared here. So y squared minus x squared. So let's just check again. AD plus BC. Actually, of course, that's not the way I should do it at all. So we take this line, y squared, AD, and it's plus or minus BC rather. So AD is y squared. No, we're doing this too early, aren't we? Because we haven't actually got. This is not a simple addition between two. This is this left-hand side of this section at the top here. It's not going to be the same. We know what this is already. But that's the thing. It's going to be y squared over x squared y squared minus x squared over x squared y squared. Yeah, I mean that is what this is, isn't it? Y squared over x squared y squared. And then it's going to be x squared. This is how I split over y squared x squared. Wouldn't you just get rid of the x squared there, the x squared there, the y squared there, and the y squared there? Making y squared minus... But you wouldn't know, this is not how it works. Yeah, see, that's what I would have done naturally. That is how it works. That is actually the answer there. But But why is that ending up in the denominator when that's actually the numerator of the top half? Alright, you know what? I'm not going to think about that too much. You know what? In this case, it's probably better to look at the other one, AC over BD. Yeah. Yeah. This time, I'm just going to look at. I'm just going to. I think I'll just concern myself with this. I like. You know what I mean? At the end of the day, fuck it. I may as well just do that one. All right. So y. That's y squared there. Yeah. So annoying this for me. Because I keep on thinking, yeah, why isn't it 2x squared y squared at the bottom? I constantly think that, to be honest. And I know I've always been that way, to be honest. But anyway, I just need to constantly think about it. It's interesting. I don't know. It's interesting some of the ways that I think about doing it. I think if I just look at this problem multiple times and then start looking at different problems as well, and I'm going to be doing that through the course of the next few episodes, I think. Anyway, well, this is about as slow as it could possibly have gone. All right, so we know that so yeah, so y squared minus x squared. Of x squared y squared. Yeah, sometimes you know what? I think maybe the problem is I'm thinking about the powers. Maybe I just haven't looked. I haven't got the right things for the powers yet. Maybe that's the answer. All right. At the bottom, got 1 times y is y, 1 times x x, and then over xy. Okay. So in this case, we've got the a over b over c over d. That's the thing we've got. See, there's three there. And this, of course, is the same as that. Over b times d over c. I'm still recording here. Okay. All right. Let's just finish this one up, and then I think we're just going to end it here because I have been waffling on a little bit here. Damn it. Fuck it. Alright, I can't even fucking scroll down at the moment. I don't know what's going on there. can't really go down for much further anyway. Alright, so what's the... Alright, let's just write this down. So y squared minus x squared divided by x squared, y squared, and it's all going to be times by xy over y plus x. Okay, this start. I mean, this at this point it's kind of obvious, but fuck's sake, what's not obvious is how to scroll down. Okay, so yeah, so we just do the ACBD thing. I mean this. Wait a minute, isn't that the fucking answer though? Alright. Huh. Alrighty. Is that what I wanted to do here? Oh yeah, I could put all these in brackets. Alright. So y squared minus x squared times xy x squared y squared times y plus x. And then we factor out here. Yeah, I mean, that's at least I understand this bit. To be honest, I do understand a decent amount of algebra, but I don't want to keep on getting irritated by that one little bit there. I can't even remember. I seem to remember that I actually do know how to do this, but I just don't know why I can't remember. Alright. Alright, so that cancels out, that cancels out, that cancels out, that cancels out, that cancels out. Alright, so that's basically going to be it for this particular episode. So until next time, thanks for watching.